The solar cycle of the sun follows what happens to the changes in the pairs of sunspots that we see rotating around on the sun. As we just saw in a magnetogram, sunspots show up in north and south pairs, where a north magnetic pole and a south magnetic pole each make a pair of sunspots. And as we saw in the previous magnetogram, in the northern hemisphere, the northern pole sunspot was leading ahead of the southern pole sunspot as the sun rotates around. And then the reverse was true in the southern hemisphere. This would be the beginning of what we call a solar cycle when we see this start to show up after sunspots have disappeared for a period of time. Sunspots disappear and then reach a peak number of sunspots after 11 years have gone by. And then they disappear again, and you have to go through 11 years again until you come to a peak number of sunspots. So, let's start at the beginning of this 11 years when sunspots have disappeared and now they start showing up again. They will mostly start showing up at a latitude of 30 degrees north and south on the sun. That doesn't mean that's the only place they can show up. That just means that's where most of them start to show up, typically at 30 degrees north latitude and south latitude on the sun. So they're showing up way up here, and in the beginning of a solar cycle, the north magnetic pole sunspots are leading in the north hemisphere, and the south magnetic pole sunspots are leading in the southern hemisphere, like what the diagram is showing down here. As we go through this beginning of the solar cycle, in the middle of the 11 years, sunspots are showing up at 15 degrees north and 15 degrees south latitude, meaning they got closer to the equator. Now again, that's not the only place they can show up, but that's where the majority of them are showing up. And then by the time we get to the end of the 11 years, the sunspots are grouping down even closer to the equator of the sun. And then they go to a point where they don't show up anymore for a little bit. Now, was that the end of the solar cycle? No, that was the end of the sunspot numbers reaching a peak every 11 years. However, what happens with the north and south pole pairs is really crucial to following a full solar cycle. When we start the next 11 years, the sunspots show up again at 30 degrees north and south latitude, but now things are reversed. In the northern hemisphere, the south magnetic pole sunspots are in the lead. This diagram is now showing that things are working the other way around. The north pole sunspots are leading in the southern hemisphere. The southern hemisphere has also reversed from what it was in the previous part of the cycle. So until we get back to the beginning of the cycle that we started with, we have not gone through a full cycle. The sunspots have to form closer and closer to the equator again until they disappear, and then they have to reappear with North Pole sunspots leading in the North Hemisphere like we started. That would mean we would have gone twice through sunspots reaching a peak every 11 years, and that means that a full solar cycle is 22 years, 2 of these times when the sunspot numbers reach their peak. So, if somebody says to you, how often do sunspot numbers reach a peak? You say 11 years. But if somebody says to you, how long is the solar cycle? You don't say 11 years, you say that the solar cycle is 22 years long.